Today's Takeo Tuesday webinars are going to be kind of interesting because it's our first twofer Tuesday. We're going to be doing a twofer Tuesday for you in that we have our session today at noontime with where we're going to talk about zone controls for circulators and zone valves. It's a more residentially focused program. And then later on today at 2 o'clock, we're going to have a do-over from last week from the commercial guys on the basics of pump selection. They broke the internet last week, man. They had more people try to sign up for this thing and get on than we had classroom size. So that's amazing to me. This week we're going to do it again. So if you missed it last week, you'll definitely get a chance to do it this week. So right now we're at 469 people. I got to get a picture of that because that's just the coolest thing ever. Hold on one second. This is for me. All right, let's see. We got 476 of you now. That's pretty cool. We're moving up. Anyway, again, welcome and thank you all for taking some time to be with us today on this Tuesday, on this quarantine Tuesday, which seems just like quarantine Monday and quarantine Sunday and quarantine Saturday. It's getting hard to tell the days apart sometimes. But thank you all guys for the gift of your time, guys and gals. We're going to have some interesting stuff today on, HVAC pump fundamentals is at 3 p.m., not at 2 p.m. It's at 3 p.m. today. With the commercial guys. So if you've already registered for that, you'll get you should have your link to join on in. So anyway, we're going to be talking today about zone controls, residential zone controls for circulators and zone valves, what they're all about, what they do, and some things you can do with them. As always, your input is welcome. I just want to make sure everybody knows how to ask a question. You should see a little cartoon balloon on your control panel that basically you click on that and that will allow you to ask a question. So I got a lot of people have typed in already. The rest of you, if you could do that, just type in a hello, hi, how are you? That would be cool. I'd appreciate that. That way I know that you know how to do this. And great, everybody's doing it. Fantastic. So ask questions as we go along, and I'll stop every so often to answer what I can. We have over 500 online now, so I'm sure there's going to be a lot of questions coming in. I'm going to try, guys, like heck to get to as many of them as I can, and I will stay on after this program is over. As long as you guys want to ask questions about this, that, or the other thing, be happy to do that for you and with you. So with that out of the way, one last thing. We've been doing these webinars a long time. One thing I have learned is for you all out there in the audience to get the most out of this, it would behoove you to treat it like a classroom experience, meaning take notes, write crap down, okay? Write stuff down like you would in a classroom. So that way you'll have a written record, and that way it keeps you focused. That way you don't zone out and go and check Facebook or something silly like that. So pretend this is an hour-long class and you are here to take notes and learn stuff. So take notes and hopefully learn stuff and then ask the questions as they come on up. Alrighty, let's get started on zone controls for circulators and for zone valves. And we're going to start real basic here, gang, with a single pump relay. All right, when I was a contractor, this is the thing I always thought I knew I should know how it works. I should know how this works. Therefore, I'm going to presume that I do and hope nobody really asks me. Okay, that happens a lot, man. That happens a lot out there. When we do this training in class, I always say, guys, this is going to be very basic. So let's make sure that you guys have, that you have the knowledge you need. If you want me to go over this again, I'm sure all of you know this. Great, but if you want me to go over it again, I'll go over it again. And then invariably somebody say, why don't you go over it again just for review? And those are the guys that take the most notes. So maybe basic for some of you, but again, it's always good to know really the basics of how these things work and what they do. What we do is we start with this guy, a double pole, double throw switch, or it could be two single pole, double throw switches. It's the same thing. You've got a common, which brings power, and then you have normally closed and normally open terminals. Normally closed, of course, when nothing's going on, that switch is closed and that circuit is complete. The normally open is open until something happens, all right? And in this instance, one item tells both circuits to change. So one thing happens, both will change like so. So they'll just go back and forth like so. It's like a switch in a relay cube, okay? If you've looked at the old style cube relays, you could actually see this inside. Now everything's solid state. But let's take a look at an old cube style relay. All right, and you see the prongs down here. You see there's a relay coil, which is a hunk of metal wrapped with copper. You have a switch right here where or I'll just draw right to it. You can see there's a switch right here, and this is the normally closed position, and this is a normally open position, okay? This is a normally open position. When something happens, we basically magnetize this contact here, and the switch kind of goes click that way. All right, so what was closed is now open. What was open is now closed, all right? So basically, this is what we're talking about. This is what we're looking at. Now, just to show you how it works inside the relay, all right, what we have here is just an artist's rendition of this whole thing. We have the spring, which you saw up here. There's a pivot. Here's your pendulum, all right, with the contact. There's a wire going from the common to the pendulum to bring voltage that way. Okay, there's power at common. You have normally closed, like so. There's no power at the terminal, so the normally open is open. And then you have coil terminals where you bring your 24 volts to power this guy up. So let's take a look at how that might work, all right? So there's no voltage here, meaning switches are open, nothing's happening, the coil is not powered, all right? So right now, normally closed is closed, normally open is open. If I had connected a circulator to normally closed and tied it back into the neutral, all right, I've had hot coming into common and tied this back into the neutral, all right, what would happen to that circulator? Right now, that circulator would just run all the time until something happened to make it not run, all right, until something happened to make it not run. If we had a circulator on the normally open terminal, well, that circulator wouldn't do anything until something prompted that pendulum to move. All right, so let's make that pendulum move. Let's see what happens now. Let's put 24 volts here, energize the copper wire wrapped around a hunk of metal, and let's turn it into an electromagnet. That electromagnet pulls the pendulum away from normally closed. It makes the contact with normally open. Now the circulator that was not doing anything connected to the normally open terminal circulates. The one that was connected to the normally closed terminal doesn't do anything. All right, it's the ultimate either or switch. Okay, it's going to either do this or that, one or the other. Those are the only choices it has. All right, so there's your basic single pump relay, and this is what it looks like, you know, in the new solid state varieties that we offer. Okay, you bring power right here, power to the neutral and to hot, and please note the jumper right here. There's a jumper right here between hot and 3 on the common. You have you have 2 sets of relays here. 2 sets of relays. You've got 3 and 4 NO and 4 NC. So common, normally open, normally closed. And then over here you have another set. 5 is common, then 6 NO and 6 NC. Without this jumper, they're both dry contacts. But with this jumper, we bring power to that contact. So we have power, we have a switch. All we need to do is connect a load to that, and we have something. On the other side, 5 and 6 NO and 6 NC, it's just a switch that needs to connect to a power supply and a load separately, and you'll see how those have been traditionally used. So let's continue. All right. So we have all of that. In the old days, when you had a single pump relay and a single pump, you'd simply wire that pump into the neutral and to 4NO. All right, into 4NO. So you turn that pump on when there would be a call for heat. 5 and 6 NO were typically connected to TT on the boiler. All right, so there's a switch. The boiler control has a power supply and has another load to do something, which will ultimately flip more switches to ultimately fire the boiler. But this is how you'd use a single pump relay in conjunction with the boiler. Now, internally, the neutral and hot wire into the primary side of the onboard transformer to provide power to that side of the transformer, line voltage to that side, and then it goes through magic smoke internally and it turns into low voltage. The low voltage side is connected like this. One side goes directly to the thermostat terminal, the other side goes to the relay, to the solid state relay. Out of the solid state relay, you go back to the other side of the thermostat terminal. You've got a power supply right here. Okay, you've got a load right here, which is your relay coil. All that's missing is a switch up top. So let's take a look at actually installing this and wiring it up and see what happens, okay? So right now we're gonna have to put in a thermostat. So thermostat goes to R and W, and this is pretty basic stuff, and the power is off to the relay coil. The power is off, see right here, it's off, and there's no power at that light right there. So what's gonna happen here? Let's turn the power on. First off, just flip the switch, turn the power on, and you'll see that the green power light on the unit itself has illuminated, so you know there's power to the unit. All we're waiting for now is something to happen, and something that happens has to be a call for heat. The temperature in the room has to go down below that thermostat set point enough to initiate a call for heat. So let's see what that looks like, okay? You'll note we have power to the primary side, and it's converted to low voltage. So I'm powered up and I'm ready to go, man. It's all set and it's all ready to go. Now, all we have to do is turn the thermostat on. So when we fire up our thermostat, okay, right now we're at 70 degrees. There's no call for heat. When we drop down to say, oh, I don't know, 69 degrees, that switch will close. All right, we complete the circuit and we now have a completed circuit. We have energized the relay coil. We have our call for heat. We have the 24 volts on the line, the low voltage side of the relay. So we're ready to go. Now let's take a look down below. What happened here is, if you take a look, we have a couple of switches. We have 3 and 4NO and 3 and 4NC. You'll see 3, you see common and 4NC. That switch is closed. Okay, and 3 and 4NO, that switch is open, and we have the same thing over here on 5 and 6. Now that the relay coil is energized, they're just going to switch places. What was closed will now be open, and what was open will now be closed. So we open the normally closed contacts, and we close the normally open contacts. So we've completed a circuit between 5 and 6NO and TT on the boiler, and we've completed the circuit between 3 and 4NO and the circulator. So the circulator is going to commence to circulate in here, all right, and the boiler is going to commence to firing. So we have both the circulator going and the boiler firing, and everybody's happy. It's doing what it's supposed to do. All right, that's the basics of your single pump relay. Now, let me take a look at some questions here. I'm sure we're going to have a bunch. All right. Let me see if I can get down here. We've got a bunch of them here. Question about the 2 fuses. Why 2 fuses? One for each switch, basically. One for 3 and 4 NO and NC. One for 5 and 6 NO and 6 NC is basically why we have both. Okay. What is my name and title, please? Well, my name is John Barba. My title is, I'd like to call myself the Lord of the Trainers, but that they won't let me put that on the business card. So I'm Director of Training for TACO, if that helps you. All righty. What is the horsepower rating of the 3 to 4 contacts? It's basically 6 amps. Both switches have 6 amp fuses. Okay, so that'll work if that helps you out. Okay. Very good, very good. Does this single zone relay basically take the place of the older method of using end switches in zone valves? Good question, Kramer. No, this is basically a pump controller. You could use this in conjunction with zone valves. You would have to bring all of the end switches into the TT portion. We have a better solution for zone valves. Okay. So let's see about that. Do we still sell ice cube relays? We don't sell ice cube relays as part of our offering. All of our offerings now are solid state, much more reliable. Replacement solid state relays can be had in aftermarket situations. All righty. So let us continue. Good questions, guys. And like I said, I'm going to try to get as many as I can here, but with right now we have over 600 of you online, so I may not get to everyone. I will seriously try, however. All righty, so let's take a look now at a multi-pump relay, multiple pump relay. All a multi-pump relay is a whole bunch of these single pump relays put into one box, all right, for convenience. I remember back when I was a contractor, all right, when I was a contractor, I looked at the price of single pump relays, and I looked at the price of multiple pump relays when multiple pump relays first came out. And it was more, a 4-zone multi-pump relay was more expensive than 4 single-zone relays. And I thought, well, that's stupid. I'll just buy the 4 single-zone relays, not realizing that an electrician had to pipe up or wire up 4 relays instead of 1. Not a smart guy. All right. So the convenience here is having all of these things under one hood. It takes up a heck of a lot less space. The wiring's a lot easier, and you have built-in diagnostics to kind of help you know where you're going to go. All right. One question here I see from Bill Rethmeyer: is this control field repairable? No. Hence the solid state controls. No. That's why we have each one of these things individually fused, so we won't have an issue on that side, on that end of it. One of the advantages of ice cube relays is, hey, one blew out, you could replace it pretty easy, right? With solid state controls, the likelihood of field failure is minuscule compared to ice cubes. But just in case, that's why they're fused. Alrighty, cool. Let's continue with our discussion on a multi-pump relay. Kind of here's what it looks like. So up top you have your zones, your inputs for thermostats. Okay. You also over here on the left-hand side have an isolated end switch. Okay, an isolated end switch. That's basically your TT going to the boiler. So you connect that to your boiler control to fire the boiler. Thermostats go to each thermostat terminal. Your circulators down below go to each circulator terminal. You have your 120 volt input, and then you have zone 4. You'll notice on zone 4, both on the input and on the circulator connection, we have priority. So if you have an indirect water tank and you want to have domestic hot water priority, or really any zone that you might want to have take priority over the others, you would connect it to the last zone. So for all of our multi-pump relays and multi-zone valve relays, or zone valve controls, the last zone is always the priority zone. So you'd connect the aquastat from the indirect to R and W there, but you're going to have to make sure that you move that priority switch, that zone 4 priority switch in this example, from the off to the on position. Now, what's going to happen here is when zones 1, 2, and 3 may be heater rate and going along just fine. And then when zone 4 calls, what happens is zone 4 will turn on, and it will tell zones 1, 2, and 3 to turn off. All right, so we stop the circulators on zones 1, 2, and 3. So all of the boiler's power and all of the juice inside is going to make domestic hot water. It's not being shared. Now, built into these standard relays is something we call domestic hot water priority protection. What would happen if something happened in that aquastat and it just never sensed that the tank was satisfied, or if there was a leak somewhere and the tank and things just kept going crazy? We wouldn't want the rest of the house to freeze up. So after 1 hour, you have 1 hour of domestic hot water priority. After that 1 hour, the control takes itself out of priority and goes back to making heat. So it's doing all 4 zones, trying its best to keep up. It's one of these emergency situations so that if something bizarre were to happen, at least the house won't freeze. Okay, it's not designed to make sure, oh, a boiler's big enough, it can make everybody comfortable. It could, but we want to make sure the house doesn't freeze. So that's the point behind priority protection. After 1 hour, you have priority for 1 hour, but after 1 hour, if something weird happens, it goes back to trying to do all 4. All righty. So I want to make sure that's explainable here, or understandable. I've used 3-wire thermostats with the common wire connected to the common on the common side, 24 volt tap, says Charles D.O. I hope this is okay as it works great. Yeah, right over here, Charles, this connection right here will help you with a 3-wire thermostat. The expandables will help you even more with a 3-wire thermostat. Okay. Why did this priority switch from zone 1 on the old ice cube controller to zone 4? It was actually on zone 1, William, on a couple of the relays. On the 4s and 6s, it was always on the last one. We all made it all zone 4 for simplicity, so we could say in every control the last one's priority, rather than saying in every control it's the last one's priority except for this one and this one. Okay, so that's the reason behind the switch, and that's really why we did it. So make sure it's all square with that. Todd Raymond says, you said after 1 hour control goes back to satisfy all four. Did you mean all three heating zones? No, it'll go to all four. It'll do all four. It's not going to say after 1 hour, forget zone 4. It doesn't know what zone 4 is. So what it's going to do is all 4 zones will be functional at that point. Okay. What triggers priority? Domestic hot water aquastat. Yes, it is the domestic hot water aquastat going into zone 4 with the priority switch on will trigger your priority. So priority comes on, the other zones will shut off. If you don't want that to happen, you just leave the priority switch off. So when zone 4 calls, and zone 4 can be a heating zone. Zone 4 does not have to be an indirect. If it's just 4 zones of heat, leave the priority switch off. You've got 4 thermostats and 4 relays, okay, and 4 circulators. If you have 3 heating zones and an indirect, and you don't want priority, you don't want to lose that hour, you don't want domestic hot water priority, well, wire it up as we show here, but leave the switch off, if that makes sense. Is priority protection adjustable? Asked Chuck LeMay. Yes, you have either on or off. It's an either or thing. It doesn't have a timer on it that you could say, I want it to be a half an hour at this point. That may be something we look at in the future, but right now it's internally set to 1 hour, okay? Does it have another timeout before switching back to priority? Asked Matt Reich. Nope, it's going to stay on, it's going to do all 4 zones indefinitely until somebody comes and figures out what the heck's going on. So it doesn't switch back and forth, okay? Again, understand what it's for. It's for an emergency situation. You got a hot water, you got a burst pipe in the hot water line somewhere. The aquastat fails. Something is not telling the aquastat that the tank is satisfied. So it's an emergency situation. After that 1 hour, it says, hey, you know, I don't want to freeze up the house. Let's go back to making heat as well. That's kind of what it's for. All right. Very good. Very good. Let us continue. Let us continue. The expandable relays are kind of have a little bit more functionality built in than standard relays. We do add a few things for you. You can expand. You can connect multiple connections together. And actually, David Porter just asked a very good question. What is the ZR? What are the ZR and CC terminals for? ZR and ZC, which you'll see down right here. ZR is basically line voltage out. ZC is line voltage in. You'll note in our controls, there's always a jumper here. There's always a jumper here, so that's kind of always closed. There are instances, particularly if you're using boilers with tankless coils, or if you want to jerry-rig some sort of priority in an older system using a newer relay and adding on, you can take that jumper out. As long as you have power in and power out, you're going to be fine. There are instances, and we have some of them in our zone control wiring guide, where you may want to do that. Most normal situations you leave it there, but there are some instances. There's some instances where you may want to take it out. So that's a really good question. After 1 hour, do you have to kill power to the control to reset it and get it back to normal priority? Yes, absolutely, Bill. That's a great question. And yes, you turn it off, turn it back on, you reset everything. All righty then. So let's continue. You have a lot of the same stuff here. Okay, you have a lot of the same stuff. Whoops, let's go back one. You have a lot of the same stuff here in that. You'll notice up here we have the thermostats. This is a 3-zone control here, all right, and zone 3 is priority here. But you have 3 wire terminals. So for your thermostats that need power, you have that. In addition, you see this expansion slot right here that says ABC. I'll show you what that's for in a second. And also note you have 2 end switches, your main end switch and your priority end switch. That's for use with ModCon boilers that have a separate DHW input, you know, to tell the boiler to high fire and get out of reset. So if you have two DHW inputs, this thing has 2 DHW outputs. All righty. And again, you have your circulator terminals down at the bottom. Now these plugs, switches, and controls. These plugs, switches, and controls, as we said, give you some expandability. First off is where it says power controls right here. It's a Molex plug. We have a couple of different add-on controls that you can use here to add a functionality to a system depending upon what it is. For example, if it's a really old boiler, All right, you could add a boiler reset control simply by plugging in and strapping on a sensor to the boiler supply and putting an outdoor sensor outdoors. You could have full or partial boiler reset for cast iron boilers. If you're using this control to power up 2 boilers and you want staging and reset and load sharing and domestic hot water priority, you have the PC702 that can plug right in, and then you connect it to the 2 boilers. So you have that that possibility available to you for adding on those power controls. All righty. And here we show the PC700. It's literally that simple. And these diagrams are available in our TACO wiring guide, which you can download during this webinar. If you go to your handout section on your control panel, there should be a button there for handouts. If you click on that, you can download our TACO wiring guide. It's about 110, 115 pages of, if you can imagine it, it's probably in that book. All right, it's probably in that book. So let us continue here. You also have switches to add some functionality as well, and we're going to talk about those in just a second. Here you show the PC702 with a 2 boiler setup and how that is controlled. The 2 boilers are actually wired directly into the PC700. They're not wired into the control, but the control will tell those boilers when zoning things happen, and it'll tell it that there's a call for heat. The PC702 will tell the boiler when to fire, what temperature to fire to, and which boiler to fire. But that's kind of how it all works. Conceptually, this is what it's going to do for you. Alrighty, now those switches, we have multiple. If you want to connect multiple relays, you can daisy chain them using that ABC terminal that I'll tell you about again in a second. But these dip switches will tell you which is the primary relay. That's the one that's connected to the boiler, and which are the secondary relays, which are tied into the primary. So you may have to make that switch there with the unfortunately named switch that we have there. You can also, in this point, turn priority on or off using this dip switch. So it's priority on or priority off. Reset normal, if you're using that PC700, you can turn this to reset, and now it'll work with that reset control. Here you have the option of turning that priority protection on or off, okay? So here's the one level of adjustability. I can turn priority on or off, and if I have priority on, I can turn that priority protection on or off if I don't want it, okay? So I have that ability there. So if there's something wrong, it'll stay in that priority protection, forever, basically. Or it'll disable that priority protection. So pump exercising as well. If you want that pump in the off seasons to exercise, you have the ability to have it do that as well. All righty, let us continue. Priority domestic hot water meaning is different. Is it meaning a different zone, i.e. car wash, shower? Correct. Yeah, it's a different heating zone. You can use it as, it can be a separate zone. And again, you don't have to have the priority on. If it's just 4 zones of heating, you don't need the priority. If you want to give a heating zone priority, you can. Usually it's used for domestic hot water. All right. So good. Priority with the PC700. Yes, that you do have priority with the PC700. You simply turn the priority on. What that's going to do is it sends a signal to override the reset and go to high limit when that priority zone does call. All righty. Now let's continue. Question, is the expansion board used by itself? All the relays have expandability. There's no specific board specifically for expansion. Our EXP relay is a fully functional relay by itself. It simply has the added feature of being able to connect to other relays. If that's what you're asking, Bruce. So I want to make sure I understand what you're saying. Okay. So ABC, the ABC terminals basically give you connectivity, and it's kind of a daisy chain. So from your primary relay, the one that's connected to the boiler, just take a 3-wire lead, just thermostat wire, connect it to ABC, and then ABC go to ABC on the next control. And then the next control, you just 3 wires into those slots again, so they're kind of doubling up, but that goes to the next one and to the next one and to the next one. So it gives you connectivity between the relays in kind of a daisy chain thing. And what you can do here is kind of cool. You can connect up to 20 controls in this manner, guys. You can connect up to 20 controls in this manner. And if they were all 6-zone controls, that's up to 120 zones. And if you got more than 120 zones, baby, we got to talk, because we may direct you over to the commercial side of the company. All right. So a couple quick questions that I'm seeing come up here. Pump exercise runtime, great question. It is switchable. If you take a look, let me go back one here real quick for you, Richard, because that's a great question. Down below here, you got pump exercise on off, and what you have the option of is you can have it run for 30 seconds every 2 weeks or 4 minutes every 24 hours, which we did that for some Canadian code issues. Up in Canada, they will commonly use a water heater as a heat source for their domestic hot water, and as a heat source for something, say it's radiant or something else. And what they require is the heating pump to be exercised so you don't get stagnant water in that line. So 4 minutes every 24 hours is their requirement. That's why you have those two switchables. I hope that answers your question. That's a good one. All righty then. Let us continue. And here we show your multiple pump relays connected together. All right, so here you get ABC to ABC. And if I had another one, I would do ABC to ABC. So ABC, 1, 2, 3, simple as do, re, mi, you and me, baby. If we are fans of the Jackson 5, you know where I'm coming from. So again, as many as you need. The primary one, the one that's connected to the boiler, is set in that one unfortunate name mode. All of the others, they're secondary. They're all set to the other unfortunate name mode. So we can look at it like that. All righty. Are EXPs and are SRs and ZVCs, are they compatible with one another? Yes, to a degree, and again, that's something you may see in our wiring guide for specifics. But yeah, control relay switches. How is this connected to a third-party controller or BACnet? They're not. That's a good question, Manuel. They're not. They're very simple boiler controls. Basically, it's a series of switches that connect your thermostat ultimately to the boiler. So it's not we're not talking about whole house control or anything like that. Simple, basic residential applications for turning your heating system on and off is really what these are designed to do. Now we're looking at future, and I don't think these are ever going to go away, by the way. They're always going to be this simple, basic package for simply turning boilers on and off and zones on and off. Will there be something more that can connect to other types of controllers? Yeah, we'll be looking at stuff like that. There's a lot of stuff out there now, and we're looking at ways to incorporate some stuff that will be able to communicate with other types of controls. So we'll see about that. We'll see how that actually pans out over the next year or so. But those are being considered by the engineering teams. All righty, let's talk about zone valves. And actually, we had a question here. Actually, Juan, can we hold on that one? I'm going to hold on that one for a little bit about the ZR and ZC, because I'll go back to that slide in a bit to show that to you. So let's talk about zone valves. We've talked about circulator controls so far. SRs, circulator controls. SR stands for switching relay. And then we have our ZVC controls. ZVC stands for zone valve control, obviously. So we can use those ZVCs to control. Actually, they're very flexible. They can control however many zone valves you might have. Say if it's a 406 control, you can control 6 zone valves, but this one control could do up to 6 zone valves and 2 circulators if you need them. Let's take a look at that and how that might work. All righty. Let's take a look here. Can please explain 1 and 2 terminals on EXP? I'm not sure I get where you're going with that, Gene. We'll get to that in a second here. And which is more energy efficient, zone valves or pumps? Asked Bill. That basic math's going to say zone valves. In terms of electrical consumption, basic math says zone valves, because you say you have 5 zones. You could do that with either 5 circulators or 1 circulator and 5 zone valves. All right. Zone valves don't use nearly as much energy as circulators. So really, you could cut your electrical consumption by about 80% by going from 5 circulators to 1 circulator and 5 zone valves, because 1 circulator is 80% fewer circulators than 5 circulators. So in terms of electrical consumption, yeah, in terms of How they're going to make the boiler work, we'll have a different discussion here altogether, okay? That depends on what kind of circulator you use, all right? So here we show in this example a zone valve job, three zones with zone valves, one system pump, and one pump for your indirect. In this example, it's a cast iron boiler, all right? It's a cast iron boiler. So let's take a gander at what this is going to look like with a ZVC control. And this is a standard ZVC control. As you can see, it's not expandable. It's your standard zone valve control board. And down the bottom, you see the three heating zones. The three heating zones are connected here, your three zones for heat. And then up top, you're going to have your three heating thermostats connected as well, your three heating thermostats, zone 1, zone 2, and zone 3. And then for our indirect, again, that's going to be connected to zone 4. All right, that's going to be connected to zone 4, and we have to turn our priority on if in fact we want priority. Now, you'll note we didn't have a zone valve on that line for the indirect. We had a circulator. How are we going to make this thing work with a circulator? Because I need two circulators, right? I need a circulator for the zone valves, and I need another circulator for the indirect, and it has to be in that either or thing. All right, it has to have that either or thing. So to make this work, we're going to make use of this guy right here down in the corner. We're going to make use of that guy, the pump end switch and the zone 4 pump end switch. Now another thing you're going to have to do here is, and we'll show it again later, remember this switch right here, this contact, that's looking for a zone valve, right? That's looking for a zone valve. Terminals 1 and 2 are for energy. That powers the zone valve. That brings power to the zone valve. But terminals 3 and 4 are looking for an end switch. Now, if we don't have an end switch here, the control's going to look for one. In order to make this do anything, what you'll need to do is put a jumper, just a hunk of wire, across terminals 3 and 4 to simulate an end switch, so that when the aquastat here does in fact call, all right, the end switch here is already made, and we can start telling these switches what to do. So you got to put that little jumper across terminals 3 and 4 on your priority zone in this setup, all right, in that particular setup. Now, with that said, let's take a look at those end switches over there in the lower left-hand corner. All right, let's take a look at what those do. If we're going to wire this thing up, first things first, we got to wire up to the boiler, right? So the isolated end switch goes to the boiler. Now, what I have down here, over here in the lower left-hand corner, is going to be my end switches. Okay, I have two end switches. The first end switch is for your pump. All right, the pump end switch that closes when zones 1, 2, 3, or 4 call. When any zone calls for heat, the pump end switch closes. All right. Now, over here, I have a common normally closed and normally open. Again, single pole, double throw switch. Single pole, double throw switch. And this switch is activated by whatever happens on zone 4. All right. It's a dead switch. I mean, it's a set of dry contacts. There's no power there. Now, when zones 1, 2, and 3 call, all right, I want my system circulator to come on, and I obviously want my zone valves to open. But I have to wire both my system circulator and my zone circulator. I have to wire both of those to that zone 4 end switch, and here's why. That switch is your either or. It's going to tell one or the other to do something. So I got to get power. So what I'm going to do is the other side of that pump end switch is going to go to common. All right. Now remember, no call for heat. This switch is open. Any zone 1, 2, 3, or 4 call for heat, this switch will close, and I now bring power to my common. All right. Now note I have normally closed and normally open. Now, when zones 1, 2, or 3 call, I want my system circulator to turn on. So what I'm going to do is simply wire the system circulator to the normally closed terminal, because this switch will be closed all the time unless zone 4 calls. All right. So zones 1, 2, or 3 called. This switch closes. This switch is already closed. this pump starts to pumpulate. All right. Now, when zone 4 closes, or when zone 4 calls for heat, your priority zone calls for heat, what's going to happen is that side's going to open and that side's going to close. Our domestic hot water circulator is going to be wired to the zone 4, to the normally closed, to the normally open terminal, so that when zone 4 calls for heat, forget the system circulator, the zone valve's closed, the system circulator shuts off, the domestic hot water circulator will turn on. Again, got to be sure. Remember that jumper goes on to onto the zone 4, 3 and 4 terminals. That's real important to make this thing work. Alrighty, very good, very good. Now, before we get into mod cons, I want to just take a quick peek at some questions here. All right. Boy, oh boy, we got a lot of them. This is excellent. I gotta get way the heck down here. Alrighty. Which is the most energy efficient? We talked to that one. What's the best control for circulators to control a 3-zone in one location and a 2-zone in another? Is there a wireless option to make that communication from the boiler? I have an existing system that has 2 circulators in a remote location away from the boiler. You're going to have to, there's going to have to be wiring involved anyway. You've got line voltage to those 2 wires. What you could do, Micah, is put a 2-zone controller out there, and then have your, if it's an expandable, your expandable, you have an expandable relay out there, and that's your secondary, and then it's just 3 simple wires going back to your primary, which controls the 3 zones, if that makes sense. As far as wireless communication between those 2, it's not anything we have, and I'm not sure if there's anything out there that can do that wirelessly, because whenever you start talking about wireless, there's always questions, but I don't know of anything wirelessly that can do that. But you can do that with the expandables and just a simple 3-wire lead. Okay, so that's the way I would look at that one, Micah. I don't know if that answers your question. Is it smarter to isolate a zone with a zone circulator than depending upon one circulator? Asked David Monroy. Hey, that's your call, man. Circulators either way are pretty doggone reliable. Okay. The argument for zone pumps instead of zone circulators is, or instead of a zone valve, is if you have one circulator for a zone valve system and that circulator goes down, you get bupkis. If I've got 5 circulators and one goes down, I got 4 circulators, which is true, absolutely true. If it simply depends on where you're at and what you're trying to accomplish. But either or, I mean, we don't take sides. You can go either way if you want. It doesn't matter to us how you zone, because we can handle you on both ends. You know, I always ask guys to say, well, hey, you got to have that redundancy. Well, how many boilers you putting in? Oh, just the one? Ah, never mind. ECM, baby. Yeah, ECM is going to save energy, electrical consumption all the way around. Don't oversell it though, because it's not as much as you might think for these little residential circulators. You get into bigger circulators, the energy savings is considerable. But these little wet rotor circulators, it's about maybe $3 a month, $4 a month, depends on how many you have and what you're running and stuff like that. Maybe $3 a month per pump might be a good way of looking at it. All righty, very good, very good. Let's take a look at now wiring this thing up with a modulating condensing boiler. A little bit different. You see the piping is a little bit different. You have a boiler circulator here, all right? And oops, where are we here? We have a boiler circulator right here, which is wired into the boiler control. Now the boiler control is going to tell that circulator to fire and what to fire to. We don't have to worry about that from a zoning standpoint. Whenever, from a zoning standpoint, when we tell the boiler to fire, that pump's going to go. All right. So we have 3 zone valves here and a system circulator, as well as our indirect circulator over here. Now, in order to get this thing to work, now we're going to look at that expandable zone valve control, which is this guy right here. All right. You'll notice we have a couple of interesting things here with our ZVC expandable ZVC control. First, you see 2 end switches. All right. Yes, we still have the expansion slots here, but now there are 2 end switches like we discussed earlier. There's the main end switch that will go to TT on the boiler, and then the priority end switch, which would go to the DHW input on the boiler to tell that boiler to override. Okay, so that's what those 2 end switches are for, similar to the SR control. We have the dip switches, we have the plug, we have the priority, etc. That's all very similar. Now, also similar to um, our standard ZVC control is the pump end switch and the zone 6 pump end switch. Now, again, it's going to be very similar. The only difference now is you see the 2 priority end switches there. So I've got my priority end switch and my main end switch. Both of those go to the boiler. But again, over here, we will bring hot to one side of the pump end switch. The other side of the pump end switch goes to common on that zone 6, in this case, end switch. The system circulators wired to normally closed, and the domestic hot water circulator in this case is wired to normally open. All right, like so. So again, now we've created that either or situation. So we can turn on either the system circulator or the DHW circulator if we have priority, so they'll work together. And then we can also speak to the boiler with 2 simple outputs. All right, so it's a way to do it, a way of looking at how we can make this thing work. All righty, very good, very good. So we've been at this. We've been at this about 45 minutes now. So this is terrific, guys. I hope this was useful to you. This is being recorded, and you will. Let's move this up here. Okay, very good. And you will be able to view this recording after we're done. You'll get a follow-up email tomorrow that will give you the, let's go end the slideshow here, hold on a second, that will give you the ability to view this recording. I can't get my slideshow to end, but that's all right. I know how we can make this work. We will do this. All right, we will stop sharing the screen. Very good. And now I'm hopeful that I'm back for you here as we share the webcam. All right, let's put that up. And there we go. Now let's go to some questions here. Let's see what we have in terms of control, in terms of questions. We've got a bunch of them here because we've got. Again, we're talking about 600 of you, over 600 of you online. So I'm going to do the very best I can here to get to as many questions as possible. All righty then. Let's take a look at some of these questions. We have some questions. What energizes normally open and normally closed switches again? Again, in the multiple pump relays, you have to make that jump from common to from the other side of that main pump relay to common. That'll bring power to the relay, and then from the relay you'll have the ability. Then from there you have your normally open and normally closed. So that can work. Some more questions here. We have. All right, now I'm down here where I'm supposed to be. Okay. By powering both pumps through the priority end switch, you have priority whether you want it or not. If that's the case, yes, you would have that priority. Well, not necessarily. Yeah, you would have priority whether you want it or not. If you don't want priority, then we're going to have to figure out a way to. Then at that point, you just wire up both pumps through the zone 4. You just leave. How would we do this? Let me think on that one, James, on how you'd wire up 2 pumps if you didn't want priority. You'd have to come up with a different strategy here, and I'm going to think about if you can use that same control. What we try to do is make this easy, that if with priority and we can control 2 pumps off of that one control. So that was the intent. Going backwards may not be, well, we'll look that one up because that's a question that I hadn't considered. But that's one thing I love about webinars. You get questions you don't know the answer to, you got to find out the answer. So that's a good one, James. Thank you for that. Is it common to have a circulator dedicated for an indirect tank, asked Kramer? Well, yeah, mostly, yeah. You could do this with a zone valve. If you just wanted to do it with a zone valve, you could. But that means now the circulator has to be sized for the domestic hot water load. And that could lead to a much, much bigger circulator than you would need for your zones. So you might run into a possibility where you'll really be over pumping the zones. All right, and a variable speed circulator is not necessarily going to know all that, so we'd have to see how that works. And a variable, so you'd have to see about that. That would be the concern of using a zone valve on your indirect. Most commonly, I see separate circulators, but you could do it as long as that main circulator is sized properly. Okie dokie. How much are the rebates for the ModCon boiler? I couldn't answer that one, Thomas. Different states are different. I think you'd have to check with the state that you're working in. Would you install flow control valves if you have 007 pumps with built-in check valves? Asks Aunt Marty. No reason to. Flow control valves, like flow checks. There's no reason to add a flow control there. In my opinion, it's not necessary, because that's kind of what the there we go. That's kind of what the zone, what the internal flow check is for. It takes the place of a flow check. So I wouldn't. There's some people who still do because they want, like, belt and suspenders, and that's okay. But it's not necessary in my opinion. All righty. One circulator with 4 zones, would it be best to use an ECM pump so it can modulate up and down? You have to move a lot more water with 4 zones being open compared to 1. That's one of the beautiful things about a variable speed pump is, in most cases, it'll speed up and slow down as zones open and close. It's the mistake people make here, Jesse, is that people think, well, it's always going to give me the right flow. No, it's not always going to give you the right flow. There's no pump, no ECM pump that is so smart that it will always give you the right flow. And there's no magic button to push to have it figure it out for you. That's a fairy tale. What it will do is it will tend to slow down as zones close, basically using less electricity, and speed up as zones open, basically using a little more electricity, but going faster to satisfy because of the changing in loads. It doesn't know how fast it's supposed to go for each individual zone. It simply knows open, closed, and it's working off of some preset algorithm. So they're very, very cool things, but they have a certain purpose. One is to save energy, and one, if you really know what you're doing, you can set it up so you get the whole system working more efficiently, but that doesn't happen automatically. So good question, good question. Here's one from Joseph Micheletti. How many zone sentry zone valves off of one independent transformer? That's a great question. Zone sentry zone valves are like 1.44 watts max, and the power oscillates. It's down to 0.34 and up to 1.44, down to 0.34 and 1 to 0.44. Basically, what you can do is you can put up to 12 zone sentry zone valves on 140 VA transformer. All right, up to 12 on 140 VA transformer. It gives you a lot of flexibility when it comes to your zoning. Okay. Very good, very good. Do we need flow regulators with a system? Commercially, always a good idea. Commercially, always a good idea. Residentially, you can. Yeah, it's not necessary. It's nice, but very few people put them on. They tend to not be worth the added cost, really, in my opinion. But there are people who do, and if you want to, well, that's quite all right. That's quite all right. Would you install flow controls on zone valves with? Oh, yep. Sorry to get off that. Yeah, we already answered that one about flow control valves. Very good. Very good. Let's see, can we distribute the slides? We're not allowed to give out the slides per se, Thomas, but you will be able to, you will have access to a recording of the webinar, and that'll be available that will be available to you tomorrow to view, but we're not allowed to give out the slides, unfortunately, sorry. Can we access your previous webinar? Asked Bill Billman. Yes, Bill, go to the Taco Tuesday section of Taco's website. So it's tacocomfort.com or taco-hvac.com. Go to our website, go to the Taco Tuesday section. All of our commercial and residential webinars are archived there. Very good, very good. Does the zone valve control have priority protection too? Yes, it does. Yes, it does, Jim. Thank you for asking. You have the same capabilities in the zone valve control as you do in the pump relay control. All righty. Issues I see on a regular basis. This is from Gary Jansen. Issues I see on a regular basis with low water content mod cons. Okay, let's see where I'm at here. With low water content mod cons. Is boiler tripping on high limit, occasionally on cast iron boilers too, when a zone, regardless if it's a pump or zone valve, is satisfied, The zone pump or valve shuts off. The boiler circulator keeps running for a predetermined amount of time, but it has nowhere to dissipate the built-up heat in the boiler, and the limit switch is open. Why not a post-purge on all zones to purge the heat out of the boiler and into the heating zones? Could be fixed, say 30 seconds. Oh, Gary, I'm so glad you brought that up. You know, we thought of that about, oh boy, 15 years ago. Our last two generations of controls, including this SR control, and it is with the SR controls, because those are more commonly used with cast iron boilers, just because it has a 30-second post purge built in. Just as you're saying, it's already built into the SR controls. Now, if that's something, and you bring up an interesting point, and I'm sure the guys that are doing the redesigns, and we should have a new line maybe within the next year, are most likely looking at that as well, having post purge on the zone valve part, because realistically, the only reason it's in the circulator control is because those are most commonly used with cast iron boilers, and it's a way to just get rid of that, get that extra heat, leftover heat from that fire into the priority zone rather than having it go up the chimney. But you make an excellent point, as it's also it could be applicable for zone valves. And that's that. I'm sure that's what the guys are working on, because we had a meeting on what those are going to be next year, and that's pretty good. Is 600 your personal best webinar? Yes, it is, Daniel. So far, so good. You guys are part of history, man. Is ZRZC always powered? ZR is. There's always power coming out of ZR. It's just a matter, ZC needs it. It needs input. So again, in normal operating conditions, you leave that jumper there, everything's good. There are a couple of instances when you may want to take that off and use it for a gazinta and a gazouta for another relay or another control, or with a boiler that has a tankless coil and requires those. So those are some things. That's when you might want to take that out. Any other circumstance, leave it in. There's no reason to take it out. All right, very good, very good. What can cause a 6-amp fuse to blow? 7 amps is one way to make it go. Could be a short, could in the wiring, could be anything like that, and that would cause it. So you've got some protection there. All right. My name again, please. My name is John Barba, JOHN-BARBA-MOUSE. No, that MOUSE is a joke. Don't put that in there. No. I think you mentioned the board self-diagnostics. Can you touch on that? Well, the diagnostics are pretty simple. And let me go back here and open up that, just get a picture of it here if I can. Let's try that again. Let's go back to the beginning. And see if we can find a picture of some diodes. Basically, they're lights, all right, on the control itself. Maybe this one will do it here. If you see these, you can see the lights on this thing. You can see them through the, well, actually, they're not on this one. Let's go back. Let's go back a slide here. Yeah, over here. Here. This is the diagnostics. It's the LED indicator. This one tells you there's power to the unit. All right, and in terms of our circulator relays, this one tells you zone 1 is energized, zone 2, zone 3, and zone 4. So they're lights on the panel itself. When you put the box on, there's little tubes so you can see those lights from the outside without having to taking the box off or the cover off. Okay, so you can read which zones are calling through the cover. On the zone valve control, there's 2 panels of lights. One is for to tell you that there's a call for heat. Zone 1's calling for heat, and then the second row of lights tells you that the end switch on the zone valve is made and the zone is actually open. So those are what the diagnostic lights are for there, if that answers your question. All righty, very good, very good. Let's scroll down some more. Boy, you guys are doing well. I got over 500 of you left. Excellent, excellent. So keep them coming. What can cause a 6-amp? Well, you can self-diagnostics. Audio could be better. Big delays. That's very well may be. It could be on my end. Could be on your end. It's interesting on the internet. You'll get this some days. You won't get it others because we're all living at home now, right? It's kind of the way that is. So sorry if there was some audio issues on your end. It could be on your end. It could be on my end. So. Who's to know? Who's to know? It could be on your end early. It could be my end late. That's the way of the world, right? When do you need to have a check valve in the pumps and when do you not need them? Asked Philip Reynolds. Check valves, whether it's an IFC or a flow check valve, are generally used in zone pumping applications where you are concerned if a zone is idle and another zone is calling, you might get flow backwards through the zone or forwards through the zone when technically you don't want it. If you were to put in a zone pump system with no checks whatsoever, when one pump is on, you might start to get a little bit of flow through that next zone and you might get heat out there when you don't want it. So external flow checks, which TACO sold for generations, can be piped into the system, or an integral flow check, an IFC, a little plastic valve that actually comes with the pump and you can put it in the pump, does a similar purpose. So it's a check valve that it's going to be hard to open without that pump being on, and it prevents flow from going in the other direction. In zone valve applications, typically not needed because when zone valves are closed, that's a positive shutoff for that zone. So you're not going to get flow through that zone. So typically they're not needed in zone valve applications, but they are recommended in zone pumping situations. Let me know if that helps you out, Philip. Are Grundfos pumps compatible with these controls? Yes, but green and green goes much better than green and red. I'll tell you that right now. Anybody's pump works with these things. It's just a power in, power out. Okay, so anybody's stuff will work with that. Excellent. Yes, I know we sell this at Flow Center there, Greg. Yeah, absolutely, absolutely. Let's continue. What else do we have down here? Boom, 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 boom. When you have slave and master relays, you also have to have your priority on the master. Yes, on the main primary relay. Yes, you want that priority on the main relay, not the secondary ones. Good point, Scott. Yes, absolutely, absolutely. All righty then. What else do we have? It would be better if those lights had two colors. Right now, the zone lights are on only when the zone is active. Yes, they are. They're only on when the zone is active. They tell you there's a call for. There's one light tells you there's power. Then one light goes on when there's a call for heat. The other light goes on when the zone valve the end switch closes. Okay. So let's take a look here. Boom, boom, boom. Can we power a water to air heat pump or should we use a buffer tank and an aquastat? What you're going to have with this thing is simply a dry contact output, if that's where you're going with this, Jeff. When there's a call for heat and we simply want to we simply close a switch. That isolated end switch is nothing more than a switch that closes when zones call for heat and zone valves are fully open. So that whatever that you can connect that switch to anything you want, as long as whatever it is you want to power simply requires a switch to get it going. I'm not sure if that answers your question, Jeff, but that is that's what we're looking at here. It's just a switch. Whatever's downstream is downstream. It can turn whatever you could turn your TV on if you wanted to, I guess. But that's how that works. The VA rating on the 24 volt transformer, they vary with the different sizes. I will tell you the zone valve transformers are much more powerful than the zone pump because you don't need much on a zone pump relay for 24 volts. There's not a lot of load there. But with the zone valves, they are more substantial. Again, it's going to vary from 40 up to 60. It depends on what you have. In some cases, we'll put 2 in there to make it work. So that's that. I hope that it's kind of a non-answer answer, but it's there. Boom, 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 boom. Can you recommend a freeze protection solution to existing hot water coils in attic air handlers? An existing freeze protection. So you just don't want that thing to shut off for very long stretches of time. I mean, the simplest thing might be to just run glycol in the system to prevent it from freezing up and the pipe bursting. I think that would be the simplest remedy. Some people don't want to put glycol in the whole system. Well, okay, then you're making a choice to further complicate this. And in that case, I would recommend, and if anybody else has a suggestion, if you want it to run a certain amount of time, you've got that. You could have it run for 4 minutes every 24 hours with that circulator exercise function. That may not be enough for what you want, and at that point, you might be looking for some sort of some sort of timer mechanism to kind of be a go-between. That's kind of how I would look at it. But to me, the easiest solution is to put glycol in it. But that's, again, I'm not sure if that's going to satisfy what the specific requirements you might have for that job. What was the title of the opening song? I think it was "This Time Baby's Gone for Good" by Southside Johnny and the Asbury Jukes. That's a good question. I can answer that one. Very good. All righty. Is there the phone line for a diagnostic tool? Those were kind of put in there for specific reasons. They were kind of prototypes, or they were there for future development and future possible add-ons that some of them materialized, some of them didn't. Some of them are used with OEM customers. So there's no real function to them at this time. Again, what you're going to see with future development, again, sometime within the next year, you're going to see some things that, some ports and things that you're going to be able to do some stuff with. So I don't know if that helps you. All righty. What would be an example of what you would use the common and normally closed terminals on a basic pump relay? Example, again, it's an either or switch, right? The way they were traditionally used, it was a simple pump relay to tie a thermostat to the boiler for multiple zones when we didn't have multiple zone controls, right? So you'd get a bunch of these things, and each one would have to turn on the boiler. Where you would use a single pump relay in nowadays, really what you do is, if you ever want to do an either or, I mean, maybe you can do, if it's a one zone system and you want domestic hot water priority, well, there's an either or switch for you. So you could certainly do something like that. But there are some other things where maybe you could use those things. If you want to power something else in the system at the same time, again, we have examples in our wiring guide that may help you there with some specific examples. I'm kind of drawing a blank right now, but I'll tell you, but make sure you do download the zone control wiring guide in your handout section. So that would be, that'll give you a lot of options there, and again, if you can think of it, it's probably in that book. All righty then, let's see what else we have. I know there were times where you can use the end switches from the zone valves as your TT connection to a switching relay. All it needs is a switch, right? If there's already 24 volts on the thermostat circuit, how would you wire a 3-wire zone valve end switch to TT? I know you can do it, but wouldn't you have 24 volts hitting 24 volts, as the 3-wire zone valve end switch shares a terminal on the motor? Our 3-wire zone valve shares a terminal. Yeah, it does share a terminal, but they don't share circuits. And whatever crosstalk within there is minimal, to the point where it doesn't really matter. All right, it's a difference without a distinction, I think. So if what you're saying is, I mean, that end switch could be used to go I think it could just be connected right to the boiler control or something else. It's an end switch, so it needs to be connected to a power supply and a load. But the crosstalk there, James, with our 3-wire zone valve is minimal to the point of insignificance. There is some, but it's not really necessary. It's not really, it is not an issue. It does limit how many you can put on that doesn't limit, but the power draw of the motor limits you to 3 on a 40 VA transformer. But again, the crosstalk not an issue, and hasn't been an issue since the late 50s when that thing first came out. All righty, Energy Kinetics recommends a 30% solution for burst protection, otherwise too much foaming through a plate heat exchanger. 30% glycol solution is going to handle you through ice age, man. That's going to handle you through an awful lot of situations. So that, to me, that would be what I'd recommend anyway. It'll keep those pipes from bursting even up in the attic, I would think. And if you glycol it and then put some Armaflex on it, you're probably going to be fine, in my opinion. But if you have to put the coil in the attic, you have to put in the coil in the attic. Those are the solutions that I can think of at this point, other than having some way of cycling that zone, regularly, so to be able to sleep at night, basically. All righty, here's one from Bruce Bloomfield. To protect my coil in the attic, I use a simple open-closed thermo switch in the attic strapped to the copper piping that piggybacks on the T&T line. So yeah, if you want to, you connect that to a timer of some kind, you can make that work. All righty. Why do they offer relay controls for zone valves? Aren't zone valves a relay? Isn't the circulator brought on by an aquastat? I'm not sure where you're going with that, Bob, but they're two different things. I mean, zone valves are low voltage. You can get line voltage ones, I suppose, if you wanted to. But residentially, zone valves are low voltage and circulators are line voltage, and we just keep them separate simply because one's less expensive than the other. We had considered, and some companies do offer, a single control that could do either circulators or zone valves. So it's line voltage or low voltage. The problem is that's more expensive than, say, a zone valve control by itself because you got line and low voltage. So you're asking these guys to pay more for a control than for a dual control just for the convenience of only having one instead, for only there only being one instead of two. So you're paying more for what you're paying more than you need to for just your simple control that's for your particular zone valve option. So that's why we don't have a combined one. It doesn't make a ton of sense, really. It sounds good in theory, but in reality, one group is, the zone valve guys are paying more than they normally would have, and what's the point, right? So that's why there are two. One's line voltage, one's low voltage, different ratings, different requirements through UL, et cetera. So that's why they're different. All right, that's why they're different. So I hope that answers your question, Bob. If I understood it correctly, can the board communicate wirelessly to a phone app? Ours, no, they cannot. They cannot. They're just simple. Again, these are simple relay controls for your basic simple residential style heating systems to get thermostats, to talk to circulators, zone valves, and boilers. Real simple stuff. There are whole house controls, there are commercial zoning packages and system controls that you can get into for more elaborate type of systems. But for your simple basic residential control strategy, these have been kind of the backbone of the industry for a good 35 years. So that's kind of where we're going in terms of simplicity. Make it simple, make it repeatable, make it doable. Now, does that mean there aren't going to be controls that kind of do other things, as you're saying? No, absolutely not. We are going to have other controls over the course of the next few years that can do other things and integrate with other types of controls as necessary. But these aren't going to go away because there's always a place for simple. All righty, very good, very good. All right, any more questions out there, gang? We still have about 380 of you on there. That's terrific. About 380 left out of our 600. So I do appreciate that. That is awesome. Let's see. Hold on one second. Let me get this screen closed. There we go. Okay. And there's my trip across Abbey Road from way back when, one of my favorite places to visit. All righty. So good. Any more questions? Can I control a pump through ZR/ZC? You could, yes, you could, out of the ZR. You could, but you still you have to have another 120 volts going back into ZC. ZC needs 120 volts in no matter what. You could use that ZR to control a pump, but you got to bring some power back in. So I guess the question, Bruce, is why would you want to do that? You could, but if you need more zones, you can expand if you want to, and you can expand to a single zone controller if you want to. It could be done, but you've got to make sure it's not just a matter of connecting it to ZR and ZC. You have to bring 120 volts back into ZC. So ZR is 120 out. You need 120 going into ZC. Primary pump used on a cast iron boiler. If you take a really good look, Bruce, that's a great question. Take a really good look. There is a terminal on the expandables for a primary pump, so you don't have to use ZR. You don't have to use ZR. You can use the expandable relay, and there is an extra set of terminals just for that purpose, a primary pump on a cast iron boiler. So there you go. So that's that. You can use ZR to control that primary pump again if you want to, as long as you got 120 going back into ZC somehow, some way. That's the important part. Okay. Could you say that a zone valve is more effective than a circulator? No, I don't think so. You could say it. I wouldn't say it's more effective or less effective. They're in my opinion, Pedro, they are different routes to the same destination, and that's delivering heat. In terms of if I'm sitting in a house, all right, if I'm sitting in a house and the heat comes on, there's not a person on this webinar or within the sound of my voice, or quite frankly, on this planet that could stand there and with the heat just coming on, say with any amount of certainty, yeah, that feels like zone valve heat to me. You size and install properly. There's no difference between zoning with circulators and zoning with pumps from a heat delivery standpoint. Now, other people might want to see you might want to see that redundancy, multiple zones. I got multiple zones. I want redundancy of circulators in case one circulator fails. There's nothing wrong with that. There's nothing wrong with that. But remember, you're only putting in one boiler, okay? And I bet you $50 that something in the firing chain of that boiler might have a snafu or a problem leading to a no heat situation. That's much more likely than a circulator failing. All right, just a thought, but that's something to think about. So is one better than the other? No. Is one less expensive or more expensive than the other? Not really. Not really. People say zone valves are less expensive. No. Circulators are less expensive. No. You got line voltage wiring versus low voltage wiring. That's the big difference. Zone valves are going to use less overall energy, electricity than circulators, because one circulator and 5 zone valves, like we said, that's 80% fewer circulators when you have for the zone valve job. So that's going to use about 80% less electricity. That said, it's not life-altering money. We're not changing someone's financial situation by doing that, but we are saving some money, and there's something to be said for that. So take your pick. What did my cousin Vinny say about good kicking or $200? Take your pick. Either way. Any problems with Nest thermostats? Yes. Oh gosh, Nest thermostats. They have issues all the way around, and that's one of the things with the new versions coming out next year. We're going to kind of address that particular problem. But with a Nest, you need an external transformer because they require a lot of juice, more juice than what's in the circulator relay or the zone valve relay. So yeah, you'll have issues. The lights will flash on them. You'll get all kinds of crazy stuff. So you're definitely going to want to use an external transformer to power the Nest thermostat. That's definitely the way to go with those. Otherwise they'll flash. Your lights will turn on and off. They'll call. They'll not call. It's kind of, we learn the hard way. Our tech services department has developed a series of diagrams, okay, for the Nest thermostat with our existing controls. Contact them, call our tech support department at your convenience, and they'll be happy to email you the list of diagrams, or the diagrams themselves, so you'll be able to see how that's done. Okay, very good, very good. Let's take a look here. What else do we have? Sounds like a good handout for the next presentation. Yeah, we will see. Nest thermostat is the worst. Some people love them, some people don't. Yeah, some people don't. So yeah, that's kind of the way they go. That's kind of the way they go. Alrighty, gang. Keep those questions coming. Like I said, I'll stay on as long as you want. That's cool. The power in my headphones went out midway through the program, so I couldn't hear myself, so I had to take them off. Fortunately, I have a backup set. Hang on right here. All right, hang on. I'm coming. I got a backup set. And now I can hear myself, sort of, kind of. Yeah, there we go. I can hear myself. Oh, and I sound good too. Excellent. All righty, guys. More questions. And if I missed a question that you had earlier, please type it in again, because I got a long list of questions here, man. This is good. Let's see what else. I'll scroll back and see if there's anything else back here. What's the difference between an HVA switch and a steam switch? Boy, that's a good question. I'm not entirely sure, Elias, where that goes. A switch is a switch. An HVA switch is just a little contact. Okay, it closes a circuit. All it does is it closes a circuit. Every circuit has the same 3 elements: power supply, a switch, and a load. The power supply delivers the power, produces or offers the power. The load uses the power to do some sort of work. Think of the motor on a circulator or the motor on a zone valve. And then the switch the switch simply completes the circuit. If the switch is open, okay, it's like a gate is open. If the switch is closed, okay, now we can continue. It's like think of it as a drawbridge. Drawbridge is open, no cars go. Drawbridge closed, cars can go over the bridge. So same kind of idea. So a steam switch, it may if it's steam activated. Again, I'm not entirely sure what that might mean, Elias. So if you, well, it looks like you left, but anybody has that follow up on that question, please share it. Please share it. What else do we have here? Self-diagnostics, we addressed that question. Very good. Taco Bell is giving away free Doritos Locos tacos today. Well, I've heard a rumor that Taco Bell is actually thinking, because they want to ride our coattails, they're thinking of changing it to Taco Bell, and I think that would be a really good idea for them. So it should be Taco Bell, not Taco Bell. That would help them out a lot. That's what I think anyway. All righty. Let's see what else we have here. Our next webinar is at 3 p.m. Pedro. Yes, the commercial webinar. It was a separate registration and separate login. So that'll be there for you. Can you send out a PDH certificate? That's going to be sent out automatically with our follow-up emails tomorrow. So tomorrow around noontime, you'll get a follow-up email that will include your certificate, as well as your certificate of attendance, as well as a link to the recording of this session. So you'll have both of those to you tomorrow, again, probably right around noontime, I would guess. I'm bummed your class in Washington State and it's everywhere got canceled, but understandable in the situations. Hopefully there's a plan to reschedule. I'd also like to get to your hands-on class. Yep, I know, Micah, that this thing threw everybody for a loop. I mean, what are you going to do? You know, I mean, it's been so long since I've gone anywhere. I'm telling you, I'm looking outside the window right now. Actually, the weather's turning pretty crappy here in New Hampshire, but we're all in the same boat together, and it's good to know that we are all in this together. And hopefully, my guess is we got another month of this, maybe through the middle of May, maybe towards the end, hopefully, and we'll come out of this. Maybe we'll be kinder and nicer too, and more appreciative of the little things. I mean, this is one restaurant in town. I'm off topic, all right? This is one really nice restaurant in town. I'm saying it's not fancy, but it's a great food, really fun to go to, really nice atmosphere. My wife and I love going there, but it's been so long since we've been there, and I kind of miss it, So I'm gonna go get some takeout. I think maybe that's what I'll do tonight. Get some takeout, and then we can just enjoy it and maybe really appreciate just the little things in life. And I think that's the big difference here. The little things in life are really gonna, hopefully for people, really gonna matter once we come out on the other side. I know I think they will for me. I hope they do anyway. How far are we from the Lars plant? The Lars plant is it's not in Nashua. Is it in Nashua? I think it's in Nashua, New Hampshire. Yeah, we're about 45 minutes from Nashua. I live in Exeter, which is about 15-20 minutes from the ocean. It's not a beach town, but it's close enough to the ocean where the property values aren't ridiculously high. But it's the home of Phillips Exeter Academy, where all the smart kids are. I never would have got in there; they would have laughed hysterically. But Phillips Exeter Academy is just down the street, and it's a nice little town, really nice little New Hampshire town. All righty, very good, very good. Let's see what else we have. That's for very good. Glad you had some valuable information there, Roger. Excellent, very good, very good. And guys, again, keep the questions coming. As long as you guys ask questions, I'll stay. We're down to 280, 279 of you out there. So as long as you got questions, I'll hang on. If you don't have any more questions, you can, feel free to sign off. I'm happy, that's okay. But if you're going to stay on, I'll stay on as well and handle whatever questions you might have about all kinds of things. How about like the fairy tale of variable speed circulators, figuring out stuff for you? That's something that's one of my favorite topics. Somebody asked about ECM and variable speed. They're great things, and they do some of the things people think they do, and they do them very well, but boy, oh boy, they don't do everything. They don't do, I think some of the things I've heard people claim they do, you just shake your head and go, no, not even close, not even close. But they're a terrific add-on to a system, and when applied properly, they have benefits way beyond what most people are thinking. So we did a webinar on that in January. Maybe we'll do another one coming up so you can really get an idea about that. What mic am I using? I am using the, what is that? That's the Blue Yeti. I'm using the Blue Yeti. All right. Picked that one up just before things went crazy online. I wasn't able to get a different webcam, so I'm still stuck with the one that's on the computer. But yeah, the Blue Yeti it's a terrific microphone, and I got the little um, mount for it as well, so I got it connected to the desk. Do you make any webinars on solar integration with the hydronic system? Have not done solar in quite a while, so not really. That's if that's something that might be a benefit, but we have some solar products, but that's probably a little bit out of our purview. But we shall see. We shall see. We do have some solar products. Maybe something that we want to think about at some point in the future. However. Could you give a little more about ZC and ZR and its application? Again, ZC and ZR, um, they were put on circulator controls for one specific reason. If you look at old boilers with tankless coils, all right, meaning it had a coil in the boiler for your domestic hot water, those had ZR and ZC terminals as well. So what this was a way of making this boiler work, if it would be that the ZR from the relay would be wired into ZC on the boiler control, and ZC on the boiler control would be wired into ZR on the relay. Now, again, this boiler has high and low limits, okay? And we need to make sure that it knows what to do and when to do it, and this was a way to make that work, okay? If you don't have a boiler with a tankless coil, chances are you're never going to use the ZR and ZC terminals on these relays. There's still a lot of them out there, so we have it available for those purposes. Now, if you were, and ZR is 120 out, ZC requires 120 in. That's why there's a jumper there. If you take the jumper out and don't do anything, the relay doesn't do anything. The relay's basically dead, so you need to have that sucker in there. Again, there are instances where you may want to take that out if you're trying to do something that's slightly off the reservation, where you're trying to power up something else when a certain thing happens. You know, when you got a call for heat on this one relay, I also want to power up something else that's going to do a second or third thing. I've got a couple of slides in a different presentation that shows an example of when you might use that, but that's kind of what it's for. And ZR, again, is that power's got to come back in to make it work. So there are instances where you may use it, not a lot, but it's there. It's there. 99.9% of the cases, you leave it alone. There's no reason to touch it. But it's there for those old um, cast iron boilers with tankless coils. All right, very good, very good. Let's guys came in with a bunch of other questions. There we go. Let's see. Do you think it's practical or fancy? I'm not sure what that means, practical or fancy, or what do I think is practical or fancy? I like to think I'm practical and fancy, but that's just me. Okay, here we go. I've had good luck with the VT2218 running on Delta T mode. It makes more sense than the Magic Grundfos Alpha. Well, the VT2218 is in my mind, it's the best residential circulator on the market because of its Delta T operation mode. It's a variable speed circulator, and it varies its speed to maintain maintain the Delta T in the system for which the system was designed. In most cases, that's 20 degrees. So bam, zones open, zones close. You know, the return water temperature is going to vary because we're not taking as much energy out of the water. So as zones close, the Delta T is going to want to naturally get smaller. All right. That's a signal for the pump to slow down so it maintains that Delta T for which the system was designed. And conversely, as zones open, the Delta T will get wider because I'm pulling more energy out of the system. The Delta T is going to want to get wider. The pump is then going to speed up. Very logical and really simple to understand. Some people lose their minds over this, which I think is outrageous and ridiculous. But it's pretty simple and it's pretty straightforward and it's pretty logical. The other part of this is what else can make the Delta T in the system go up or down, and that's basically how cold it is outside. When it gets colder outside, there's more heat loss to a room. That meaning that room's going to pull more BTUs out of the baseboard or out of the radiator, meaning the Delta T in that zone is going to get wider. That means the pump's going to speed up. So the pump's going to go faster in January than it goes in either October or April. Again, people think this is a crazy concept, but you just look at the darn thing work. It makes a ton of sense. So it's as close as you can get to a circulator that'll kind of figure it out for you, but it's not 100% accurate to say that. It's not something you'd hear us say anyway. Were you referring to the ZVC 406-4? Why would you want to have a relay control when you already have zone valves to act as relays to close T&T? We feel it's an extra wheel on the cart. Okay, I'm not entirely sure. I'm trying to visualize your point there, Bob, but I'm having a little bit of trouble. You know, if you're talking about the zone four relay switch and the pump relay, okay. Again, these are designed to make wiring easier, less cluttered, and just simpler all the way around. So I'm not entirely sure where you're going here in terms of a relay control. Yeah, you wouldn't necessarily have to wire up your end switches back in through the relay. You could wire them to something else if you want. There's nothing to stop you to do it. But this was done for convenience, for neatness, and for simplicity. If I'm understanding your question correctly, I may not be. You said you had problems with the Nest thermostat on a zone valve controller. What about an Ecobee thermostat? Again, I'm not specifically certain about the Ecobee. If it has similar power requirements to a Nest, then you're going to have similar issues. You know, so those are things we hope. It just depends on the Ecobee and which Ecobee it is and how much energy it demands from the control. And you'll find out pretty quick if in fact that if in fact you don't have enough, because it'll go kind of haywire right off the bat for you. It's not going to work for a while and then be a problem. It's a excuse me. It's gonna show itself right off the bat. So very good, very good. Boom, boom, boom. Let's see. Good looking too. Thank you, thank you. I've heard that 2218 circulators are really not a good fit for ModCon boilers. I'm not sure who would say that. I don't think any variable speed circulator set to a variable speed mode is good for a boiler circulator. All right. Those boiler companies have their idea of what that boiler pump should do and how it should be controlled, and we leave that to them. On the delivery side of the system, yeah, no, why wouldn't it be a good choice for a ModCon? I don't quite understand it, because it's always going to bring the lowest water temperature back to the boiler because it's maintaining that 20-degree delta T. Now, if short cycling is always going to be an issue with whether it's a delta T pump or a delta P pump as a system pump, if you get less water coming back and that boiler's firing, that boiler's going to short cycle like crazy. In either case, I'd recommend, if you have a lot of zones, in either case, I'd recommend a buffer tank to add some to add some mass to that system to reduce that short cycling. If that was the objection, it's people who say that just kind of poo-poo delta T anyway and try to find reasons to discredit it. And obviously that's kind of where it is. No, it's fine. It's fine. You just got to know what you're doing with it and make sure if you have a lot of zones, a buffer tank is really going to help in any situation. It'll make a delta T pump and a ModCon, actually, that to me, a delta T pump on the system, a buffer tank and a ModCon working in conjunction. Now you've got the very, very best possible heating system you have. To me, that's the best of the best. So that's the way I would look at it. Let's see. It's not an extra wheel when you can diagnose which zone valve is in a failed condition. Okay, I guess so. Pump with check valve, don't need flow check. No, if the pump has an integral flow check, in most cases you don't need an external flow check. It would be one more wheel on the cart. There we go. Let's look at it that way. Very good, very good. What else do we have here? Off topic, Takeo Genie for tankless. Have any plans to modernize for automation and integration with smart home things? It would be nice to have more options. Always looking at those kinds of things. In terms of integrating with home control systems and that. There's it's the weird thing about that, Mike. It's a moving target. So what we come up with, we may say, okay, we decide today this is an example, but today this is what we're going to do, and by the time it's done and ready, the technology's changed. It becomes passe, if you will. That's always a concern with those sorts of things, and integrating with smart home controls. Yeah, we'll see how that works out. But yeah, we're looking at wireless enablers for the Genie for tankless. We're looking at other options for tankless as well, because you want to make sure you don't want to run a tankless a recirc line for a tankless off of a timer. You'll burn the tankless out in no time. So there has to be more of an on-demand kind of approach. And basically that is what the Genie does. It's an on-demand. You press a button and bam, it comes on. People say, well, could a flow? Could that be enabled by a flow control? By then it's too late. You want to turn that thing on, high head pump, bam, get the water to that farthest fixture. So when you turn the fixture on, you're ready to go. I mean, we want to try to get that to be around 20 seconds. So how does that work in, let's say, a smart plug that learns your usage? The concern again is with automation, is the automation saying go ahead and do this when there may not be a call for domestic hot water. Those are, for every reason you have to do it, you can come up with 4 not to do it. So we'll see. That's all in process, Micah. And you never know what'll come out in the next 6 months to a year and a half. Okay. Very good, very good. All righty. Can I help you do a buffer tank class? You can help me do a buffer tank class, of course, of course. Isn't using a low loss header helping with short cycling? It certainly can, depending upon the water content of the low loss header. Yeah, it certainly can help. A buffer tank, if you've got a lot of little zones, all right, a lot of little zones with a really low water content boiler, then a buffer tank will help you more than a low loss header. A small number of zones, just a few zones, a low loss header might in fact be enough. Yeah. It just depends on how much water's in the low loss header. If there's a good amount of water, yeah, you're good. If it's something really, really small, it may not have enough. It may not have enough to make that work. So again, you got to know what you're working with. So I can't give you a blanket answer there. I can say, yeah, like anything else, it depends. Yeah, I love that answer. It's an all-purpose answer, and it's gotten me out of a lot of trouble, both at home and professionally. All righty, very good, very good. Anastasios, thank you. Thank you for the kind words, appreciate that. All righty, folks. God, we're still 188 of you out there. My goodness. I would expected you to flee right after 1 o'clock, but we're going on an hour and 37 minutes. So again, whatever questions you have, at this point, I'll stay on as long as you guys can, or can stand listening to me. Let's put it that way. I'll yak away till the cows come home. Anybody who knows me knows that talking is not a problem. All right. My only marketable skill is the ability to talk 3 days straight without getting bored or tired. And that's what I do. All righty, very good. So what else do you guys want to talk about? Let's throw this out at you as a provocative question. We talked about zone valves versus circulators. Let's talk about, I'll go back to talking about variable speed pumps. Here's a question. Can you still get the 008 VDT? Yes, you can. Absolutely. You sure can. I don't know what the stock situation is, but it's not a dead product in our catalog, so you most certainly can get one. Let's see. Thank you for taking the time. All right, very good. Thank you, Emin. I appreciate you joining us. So terrific. Again, now I just lost 8 of you. That's not bad in the last few minutes. But variable speed circulators, I've heard people say, if you use one for a zone, it's not worth using a variable speed circulator as a zone pump. And the rationale is, if you know how these things work, you'll know that as a zone pump, it'll never vary its speed. Well, that's true of a delta P pump. A delta P pump, like our 0015E3, our 007E, our 0018E3, or 0018E rather. They're delta P circulators, and what'll happen with those is they're simply going to pick a speed. Wherever you set it up, wherever the system curve intersects the pump curve, that's the speed it's going to go. It's never going to vary its speed. So people say, why bother doing that? Right? Why would you do that if it's not going to vary its speed? Why use it? Well, it may find its point at maybe working at 20 watts instead of 80 watts. All right. And it may, depending if you know how to program, particularly a 0015E3, you may get your performance line so close to that we try to maximize the system delta T for as much of the heating season as we can. All right, we can reduce over pumping the system as long as we know how to set it up and what the requirements are. So there's a double benefit there to use for using it as a zone pump application. Even though people say, well, it's not going to vary its speed, what's the point? Well, the point, varying its speed isn't the point. The point is it's going to pick the speed that it can work on where the system curve intersects the pump curve. And if you know what you're doing, you can make it work even better. All right. Magnets with ECM circulators. Are you talking about magnetic dirt separators, Matt? Because that's a very good question. Do you need a magnetic dirt separator with ECM circulators? Not ours, all right? It's never a bad thing. Putting in a magnetic dirt separator is never a bad thing to try to keep that crap out of the boiler. But for our residential ECM circulators, we don't require one. Others do, but we don't because we have something built in called Sure Start. So if it were ever to happen upon a locked rotor situation, if the rotor ever got locked because of black iron oxide or other crap, what our circulators will do is it goes into Sure Start, meaning it'll oscillate or rotate that impeller back and forth really aggressively, full speed this way, full speed that way, rock it back and forth like so to try to break itself free. And it does this up to 100 cycles over a 20-minute period to try to break itself free. Now, in the wild, what we've seen is 3, maybe 4 cycles is enough to break up the worst locked rotor situation. But after that hour, if it still can't get itself free, it figures something's stuck in there, man. And what it'll do is it'll simply shut the pump down. And the LED will turn red. We're not drawing any more power, and that's a signal for someone to come check it out. Compare that to a standard circulator. When that rotor's locked, the power stays on. The power is always on, trying to move that rotor. It doesn't know that it's locked. It just knows that it's not moving. So the result is the circulator itself gets incredibly hot. If you show up because of the no heat call in time, you can see that it's incredibly hot. If you don't show up in time, the circulator's dead and you got to replace it and you don't know why. All right. And that can happen to other ECM circulators as well. That's why other ECM circulators require that magnetic dirt separator to get that black iron oxide, bio, black iron oxide out of the system. All right. And other magnetic crap and other just crap in general to get it out of the system so it doesn't affect their circulators. Our circulators are kind of impervious. The boiler's really the thing you care about. So hopefully that answers your question. Our circulators also have what's called a bio barrier. It's kind of a fail-safe, a double fail-safe. Now, along with the Sure Start, we have a brass mesh barrier that will basically make the magnetics in the motor invisible, because brass is not magnetic, right? It makes the magnetics in the motor invisible to any magnetic crap that happens to be in the water. So it's not going to want to be attracted to that anyway. So the two things together make this a kind of serve as a fail-safe for that circulator. All righty then. What else do we have here? I have a hard time getting one of my projects to work in the Delta T programming. It gets down to 1 gallon per minute and then reaches 10 to 12 degrees differential and no lower. Okay, Jeff, help me out with this one. What are you wanting it to do? You've got a minimum speed there. I guess maybe this might be where you're going with this, Jeff. The 2218 has a minimum speed. And when the speed just drops, and then finally hits that minimum speed, that's all it does. It's not going to get out of there. It's not going to go any slower. So at that point, it is a 9-watt fixed speed pump. All right, that's a 9-watt fixed speed pump, and that's that. So if that's where you're going with this, I may not be understanding your question properly, but it's gonna slow down to 9 watts, and now it's a 9-watt fixed speed pump. And if the load goes down below, and I really need it to run lower, then I'm over pumping. If I'm over pumping, I'm going to have my delta T is not going to be 20. It's going to be something smaller and smaller and smaller the warmer it gets. That's just life. All right, that's just life. So like I said, the delta T pump is going to vary its speed until you hit that minimum speed, and you'd be amazed how much of a normal heating season you're going to be at that minimum speed. Delta T works best on the larger the system, the better it works. If you've got like a zone valve system that needs like 6 gallons a minute at 4 feet ahead or 5 feet ahead. Boy, Delta T is going to do some stuff for you when it's really cold out, but you're going to reach a point where it's now a fixed speed pump, which isn't a bad thing. It's a fixed speed 9-watt pump and it's going to work just fine, but it's not varying its speed. It might be an expensive solution to a problem that could be solved a little bit less expensively. So it's a value proposition at that point. All righty. Is there a way to set up a system that all zones would be open until one zone called for an additional heating load? Bruce, are you referring to? I guess that's the way I'm reading your question, Bruce. And please correct me if I'm getting it wrong. To me, that just you're talking about priority zone, right? So all zones would be operational. Then when the priority zone comes on, the other zones shut off. If that's what you're talking about, all right. Let me clarify if I'm not understanding you correctly. Okay. I'm wondering in a lower outdoor weather if I should lower the buffer tank aquastat top temp to use or dissipate BTUs. So I'm wondering in lower outdoor weather. So when it's warmer out, should I lower the buffer tank aquastat top temp to dissipate the BTUs? Should you lower the, okay, boom. Jeff, I'm going to ask you to rephrase that because I'm not sure I'm understanding where you're at here. If you could rephrase that for me, and take your time, because I want to make sure I get it right. Then I want to be able to answer that, but I'm not entirely sure I understand the question. And you'd be amazed how often in my life I've actually said those words. I don't understand the question. There we go. Can I put boiler pumps, valves in the upper stories in the home instead of putting them in the basement in case I don't have a basement? Yeah, there are a lot of homes that don't have basements. They're slab homes or they're on crawl spaces. As long as you can vent it properly and safely and legally, yeah, then you could put them in a closet. You could put them wherever. It depends on the structure. Absolutely, yeah. And are there disadvantages? Not really. No. Just as long as you are able to properly vent the boiler and properly vent the boiler and have appropriate combustion air. And if it's a sealed combustion boiler, you won't have a problem. But yeah, there's no real disadvantages if I'm understanding you correctly, Siddharth. I appreciate that. Good. Okay. All right, I'm waiting, Jeff. If you can restate that question. Any other questions? Pop them on in. We're still holding steady at 151. There's 151 of you out there. My goodness, 47 minutes after the end of the session. So either I'm just enthralling or you guys just have nothing else to do. Oh gosh. Hey, this is great though. If we're gonna make the best use of this time, let's make the best use of this time, huh? Let's have a good time and make it all work for us. Alrighty then. Any other questions out there, folks? Oh, okay, here we go. Once the variable speed pump reaches minimum speed, then I'm hoping to reach a delta T setting. So if I lower the temperature use by if you lower the temperature use, all the energy by pumping a lower. Okay, okay. If I understand you correctly, I mean delta T works very very well with outdoor reset. Okay, lower water temperature, pump's still trying to maintain that 20-degree delta T. If it's maintaining that delta T as much as it can, well then the boiler's just going to love that, because that's lower water temperatures going back to the boiler. So the boiler likes that. Now, if you want to lowering the temperature in a buffer tank's just like working with outdoor reset, basically. Okay, if that makes sense. So yeah, again, you lower the water temperature would really be no different than connecting it to having outdoor reset. So yeah, but again, you're still going to reach that point because GPM equals BTUH divided by delta T times 500. You're still going to reach that point where at minimum speed, the pump's just still going to be over pumping, and the delta T is going to get smaller. You might have a little longer run times, but the delta T will still shrink no matter what you do to lower the temperature in there. It's still going to happen at that point. All righty, very good. Zone 12 zone valves on a 40 VA transformer, asked Richard. Yeah, um, we've tested these things, and with the zone sentry zone valve, which is 1.44 watts, bops up. If you were to put a zone sentry on a watt meter, on a power draw meter, it would be doing this. Okay, it would be going poof, poof, go up to 1.44 down to almost nothing, 1.44 down to almost nothing. What the power draw is intermittent. Okay, the power draw is intermittent. It's not sustained. So what's happening is we're just pulsing energy into the onboard capacitor of that motor. Okay, it's a zone valve. So when the zone valve is open, we don't need constant power on that zone valve to keep it open. When a ball valve's open, it's open, right? All we're doing is we're keeping that capacitor, that onboard capacitor in the motor topped off with juice, so that when the call for heat is done and we kill power to the zone valve, the stored energy in the capacitor will be enough to drive the zone valve closed. Okay, so that's kind of how it works. So to do that, it's 1.44 watts to almost nothing, 1.44 watts to almost nothing. In that configuration, we have determined on 140 VA transformer, you can run up to 12 of these things with really no problem whatsoever. And we always err on the safe side, okay? We always err on the safe side. So that's where we're at with 12 of those zone sentry zone valves on 140 VA transformer, okay? If that helps you. All righty then, thank you. All right, a mod con with zone valves and an indirect is the same as zone valves with the mod con combi boiler, AKA the HTR VersaFlow. A mod con with zone valves and an indirect is the same as zone valves with a mod con combi boiler. Sort of, kind of, yeah, except you don't have the storage. The combi is going to be like a tankless type of water heater. So yeah, it's functionally, I think if you're going into priority, that's what's going to happen. It's not a whole lot different. I had an NTI matrix in my house back in Minnesota. It was essentially the same thing. It had an internal heat exchanger to make water and an internal circulator, and then a three-way valve, so that when you're in the heating mode, boom, we're making heat. When there's a call for domestic hot water, boom, priority. So it's the same thing, only different. Maybe that's the way to look at it, Rick. It's the same thing, only different. All right, very good. Good point. Very good. All righty. Terrific. Any more questions, guys? An hour and 52 minutes. Holy crap, guys. This is awesome. This is awesome. You guys are doing terrific. I'm glad you guys stuck around. This made my day. It really did. See you at 3. Actually, you won't be seeing me. You're going to be seeing the really smart guys. You're going to be seeing Brett Zerba and Rich Medeiros at 3 o'clock. Two of the smartest people I've ever met. And I have the great pleasure and honor to work with these guys. Between Rich and Brett, man, they will wow you with what they can share with you. They're really two of the sharpest heating pump people, commercial systems and commercial pump people I've ever met. Just terrific and really knowledgeable. You will enjoy that session. It's going to be well worth your time. All righty, I'm looking at my phone here. It's 1:53, and I just had a package delivered. Oh boy, I love getting it. You've been quarantined a little too long when getting the mail is like the highlight of your freaking day. That's kind of like, wow. All right, I'm excited now. I can't wait to see what I got. One thing from Bruce. In a different class, we talked about the minimum system pressure. I have a water coil in the attic. We have lost pressure to the system down to 1 to 2 psi. Is the water in the attic becoming airlocked by pulling the air out of solution? If you don't have enough fill pressure, yeah, that could be. That's one of the things that happens. The lower the pressure on a fluid, the more that dissolved stuff is supposed to that dissolved oxygen will come out of solution. So it's possible. Yeah, it is possible. I would wonder about how we've lost pressure. All right, because there's pressure just doesn't go away. Pressure's got to go somewhere. It's got to be there, and then it's not. All right. More often than not, that's a leak somewhere, and I'd want to know about that. I'd check that out. If you're losing pressure in the upper portions of the system, you want to know why. Typically, again, you got 12 psi in the basement is good for 27 and about 27 feet. All right. And you want a little bit left over. So you're really talking about 20, 22 feet. If you need to go higher, well, then you need to boost the pressure in the fill pressure in the system more. All right. By adjusting your pressure reducing valve. And whatever you change the fill pressure to, you also have to adjust the pressure in the water side or the air side of the expansion tank. So that's got to be, if that's charged to 12 and you want to run it at 15, you got to bump that up to 15. Problem is you can't do it. You can't do it when it's connected to the system. You have to do it when there's no water pressure on the water side. So you have to figure out a way to isolate and drain that, boost that up to 15 psi, boost your system pressure up to 15 psi so they're the same. Otherwise, the tank's going to be too small and you're going to pop a relief valve most likely. So that's kind of the way of looking at that if you want to boost your system pressure. But I'd also, Bruce, I'd look around and see where might that pressure be going. And one way to lose pressure is to have a leak somewhere that you don't know about. And maybe you do know about it, but there aren't too many ways for systems to actually say, you know what, I don't have any pressure. So something to look at on your end. All right, should I install an outside temperature sensor on my newly installed boiler to improve the efficiency of the system? Well, yeah, outdoor reset is a great way to improve the efficiency of your system, simply because you know, as the outdoor temperature changes, the heat loss of your house changes, right? And as the heat loss of your house changes, the output requirement of your boiler changes. And one way to change the output of your boiler is to change the water temperature. So the lower the water temperature, the less energy it uses. The more water temperature, the more energy it uses. So it's been outdoor reset, guys, has been around since the 40s. Okay. It's not a new technology. There's new electronics for it, but it's not a new technology. It's not a new concept. So yeah, absolutely, it's a low-cost way to save money. Yeah, especially if the boiler is equipped with outdoor reset. They usually come with it. You can't buy a boiler today, cast iron or mod con, that doesn't have outdoor reset. It's there. It's a no-cost way because it doesn't cost you anything. All right, it doesn't cost you anything. You bought it when you bought the boiler. Connect the sensor outside, make it do what it was meant to do. All right, make it do what it was meant to do. If it's an older boiler that does not have this, then there are ways to add outdoor reset to that older boiler. The PC700 is one way. There are others that you could add to an older system that doesn't have outdoor reset. If it's a cast iron boiler, you have to do partial reset so the water doesn't get too cold going back to the boiler to cause flue gas condensation. But it's still a great way to save some energy, and can be done very easily and simply. All righty, gang. As this merry time continues, let's see what else we got. Any more questions? I'm gonna do one last call for questions, and then I'm gonna shut her down for the day. I do appreciate everybody's time and input. This was a lot of fun. I really appreciate the questions, and I really appreciate you guys hanging out for so long. That's very gratifying. Thank you. And I hope this was useful for you. And you have a good day as well, Anastasios. I'll get it right. Thank you, Anastasios. You have a good day as well, sir, and be safe. And hope everybody out there staying safe, and your friends and family and loved ones are all healthy and getting through this thing with a smile on their face, because that's really all we can do, right? That's all we can do. Just keep on smiling, and someday we'll be able to go outside and play, like golf. My God, today's not a golf day, but I can't wait. I'm getting itchy. All righty, folks. Thank you all. Have a fantastic rest of the day. Hope you enjoy Rich and Brett. They're going to put on a fantastic show for you as well. And take care, everybody. We'll see you.